This is the final project for MEC 203 by Group 27. The project is called the Adventure Rover, and it is based on the Mars rover Curiosity that was sent to Mars at 2012. And here is the 3D model of this design. So here is a exploding view of the entire model, entire design. You can see it is joined together by a lot of rotating joints, such as the wheels to the drivetrain to the chassis. So the design process for this rover starts from picturing the general shape of the rover. So here I have a basic box drawn with a simple arm at the top and drivetrains on the side. So this is my initial design philosophy, and I had three features for the rover I had in mind when I started out the design. The first being a foldable drivetrain skeleton on the side of the rover, and then here I have a part that does exactly that. This is called the drivetrain skeleton connector, which connects the drivetrain to the chassis, and then it has a rotational capability that will kind of flip the drivetrain skeleton upwards and lay the tires flat with the chassis. And the second feature I wanted to have in the rover is the ability to turn the front and the rear wheels about the center of the entire wheel. And this component is called the turner, where its whole job is to connect the front and the rear wheel to the drivetrain skeleton, allowing it to turn about its central axis. And the last feature I wanted in this design is to have a sample collection clamp that has a little drill bit in the middle. So here I drew a part, a design for the sample collection system, that where it has two axes of rotation, and on the outermost bracket there is two clamps that can clamp together samples and put it into the built-in laboratory of the chassis, and then there is a little drill in the middle. So here are some motion studies for the rover. The first one is the basic mobility system. As in here you can see the wheels are turning, and the drivetrain skeleton is responding accordingly, as if there are debris underneath the rover. And then the next motion study is a turning motion for the wheels. As you can see, the front wheels and the rear wheels are able to turn while the wheels in the middle stay straight. And the next motion study features the folding mechanism that I had in mind when setting out to design this project. As you can see, the wheels is able to fold from the driving position all the way to lay flat along with the body of the rover. And then next I have a motion study for an example that how the arm will work as it is collecting samples from a rock or anything like that on Mars. As you can see, the arm has two linkages and it can extend outwards. Okay, next there is a motion study that provides a sample view of how the deposit of samples would look like as the sample collection arm goes to the body of the rover. As you can see, there is a little lid on the rover that opens up as the sample collection arm comes in, and then the jaws will open, and then it will drop the samples into the built-in laboratory.